All right, so for today we're going to do a couple of things. First thing I want you guys to do is get some practice with finding percents using z-score and normal CDF on your calculator. Then we're going to learn a lesson on finding x value, and you're going to get some practice with that. We should all have this worksheet. What I want to do is work through one of them before you try one on your own, just as a refresher. So when we're working out these problems, it's a two-step process. All right. First off, look at they're asking for probability. Another word for probability would be percent. So they're asking us to find a percent. When you're looking to find a percent, probability, or a proportion, it's a two-step process. The first thing we want to do is find z. Our formula for finding z is x minus mu divided by sigma. Once we get z, we're going to use normal CDF. So if it's a less than problem, we're going to use normal CDF. Our less than rule is negative 99 comma z. If it's a greater than problem, we're going to use normal CDF. And it's z comma 99. And if it's a between problem, let's go today. A between problem, and we want to use normal CDF and z1 comma z2. Right, so let's work this one out. This problem says the distribution of weights of toddlers is approximately normal with a mean of 25 and a standard deviation of 5. Weights above 30 pounds are considered overweight and must be looked into. I'll find the probability that a toddler has a weight greater than 32. So here's our mean, here's our standard deviation. This is actually our x value. This 30 over here is just added information that we don't need. So to find x, or to find my z, I'm going to take 32, which is my x, subtract out 25, divide that by 5. That gave me a z value of 1.4. This is a greater than problem, so I'm going to use my greater than rule. So I'm going to do normal CDF. I'm going to go 1.4 with my z, comma 99. This function is on your second bars in your calculator. So we'll go to second bar, make sure you choose normal CDF. And when you punch that in, it gives you 0.0808. We want to round this to 4 decimals, and then you can convert that to a percent. So that's 8.08%. And that indicates that 8.08% of toddlers weigh more than 32 pounds. All right, part B. What percentage of toddlers have weights between 25 and 32? So I need to find two z's here and follow the same process. Step 1, find z. Step 2, use normal CDF. So the z for 25, I'm hoping or you may be knowing this already. It equals the mean, so our z is 0. When we find the mean for 32, we already have it, but I'm going to show you again just to be clear. That gives us 1.4. So now I have my two z's. I'm going to use my between rule, which tells me normal CDF is z1 comma z2. My z1 is 0, that's the lower number. My z2 is 1.4, the larger number. That gives me 0.4192, which I'm again going to convert to a percent, which would be 41.92%. All right, part C. Find the probability that a toddler has a weight below 22. So this is my x. I'm going to find z by doing 22 minus 25 over 5. That gave me z value of negative 0.6. I'm going to go to normal CDF. It's below or less than, so I'm going to use negative 99, comma negative 0.6. And that gave me a percent of 0.2743, which I'm going to convert to 27.43%. So this is the work I'm looking for. I'm looking for your z. I want you to show me what you plug in your calculator, and then you can leave the answer as a decimal or percent. I just think it's more meaningful if you convert it to a percent. Okay, so now that you have this example to refer back to, I'd like you to complete number 2 and number 3. After you're done completing number 2 and number 3, then pull out your notes, and we're going to look at, I believe it's page 9 or 10. I think it's page 9 or 10 we're going to look at. Okay, so it is page 10 in your notes. It says finding a specific x value. So let's talk for a second on what this means. The previous problems we were just doing, we were looking to find a percent, a proportion of certain individuals that were in a specified range. These problems, we're turning the process around and we're looking for an x value. For instance, what height would put an adult male at the top 90% of all males? Right? What salary would you have to make to be at the top 5% of salaries in the United States? So now we're looking for an actual real world value, not a percent. So that's the first thing you need to recognize when you're starting these problems. All right, so this is the main slide that's going to give us what we need to solve these problems. It says finding a specific data value. You can use the normal distribution to find specific data value and x value for a given probability. Right, now your notes look a little different because this year I decided not to use the table, so step 2 is now a little different. Step 1 says take the percent from the problem and write it as a left or a lower problem. So this can be a bit of a problem for many. So I'm going to give you a couple examples on what that means. If it says the problem is talking about weight, and it says what weight would put you at the top 10% of weight. So they want the top 10% of weight. So that value would be over here. This would be 10%. What we have to do, because we talked about how our normal curve is cumulative from left to right, so our calculator is programmed to add up from left to right. It works in the left direction. So I have to write my problem as a left problem. So the area or the decimal I would want to use here is 90. So I would actually use 90, and that's what I'm talking about. If they talk about the top 20%, right, top 20, then I would use 80. So I need to use 80 in this process. If they said the bottom, right, they said the bottom 10%, then I'm going to use 10% because that is the left. So I always want to figure out what the left value is. This would be 80, and this would be 90 here. And this on the left is 10%. Right, so we'll see that again when we look at some examples. After we write the problem as a left problem, we're going to use this function. Right, your notes say something about a table. We're not going to use a table. We're going to use this function. It's called inverse norm, and it's under that second bar. So if we go second bars on our calculator, we should see the third one down. It says inverse norm. Right, and what we're going to plug in there, we're going to go inverse norm, and I'm going to plug in the area. So our area, depending on what the problem is about, that area is going to be what we're going to plug in there. This function gives us z. So when you hit equals, it will give you the z value. So we're working backwards to find the z value that corresponds to a specific area. Okay, so once we find the z, which we're using inverse norm to do, we're going to then use this formula. So step 3 says use the formula for changing z-score to an x value. And our formula is x equals z times sigma plus mu. So that's z times the standard deviation plus the mean. So again, we're going to walk through this process again. I'm going to write the percent given in the problem as a left percent. Step 2, I'm going to use inverse norm to find z. And step 3, I'm going to use the formula which helps me evaluate x. Alright, so here is an example. Example 1 says scores for a civil service exam are normally distributed with a mean of 75 and a standard deviation of 6.5. To be eligible for civil service employment, you must score in the top 5%. What is the lowest score you can earn and still be eligible for employment? So step 1, I want to write this as our left percent. So I'm going to draw a curve, and you don't have to draw the curve. I'm trying to give you a visual of why we're writing it as a left percent. So that top 5% is right here. So this is 5%, 0.05. Okay, so what would this percent be right here? This percent would be 0.95. I need to write it as a left area. mark is 95. So I'm going to use 0.95 as my area. I want the top 5%, so I have to write it as a left problem. To the left of 5% is 95%. Second step, I'm going to use inverse norm, which is in my calculator under second bars, and I'm going to plug in that left area. So I'm going to go inverse norm, plug in the left area, hit enter, and this gives me the z-score. So this should give you a z-score of 1.644, which we're going to round to 1.64. My third step is I'm going to use the formula. The formula is x equals z times sigma plus mu. So I just found the z value, 1.64. I'm going to multiply that by my standard deviation, which is 6.5. And I'm going to add the mean, which is 75. So this gives me a score of 85.7. Let's interpret the 85.7. This means that in order to be eligible for employment, you must score an 85.7 or higher. Again, to be eligible for employment, you must score an 85.7 or higher. All right, next example. The length of time employees have worked at a corporation is normally distributed with a mean of 11.2 years and a standard deviation of 2.1 years. In a company cutback, the lowest 10% of seniority are laid off. What is the maximum length of time an employee could have worked and still be laid off? So they want to cut off the bottom 10% in regards to experience at this company. I'm going to draw the curve again just to show you where the 10% falls. So it's the bottom 10%. That's right here, 0.1, 10%. Okay, so they're talking about the bottom 10. They want to get rid of the bottom 10. So I'm going to write this as a left area. Well, what's left of 10%? 10%. So I'm going to use 0.1. Right? I want the left area because my calculator is programmed to work from the left. My second step, I'm going to use inverse norm with my left area. This is giving me the z value. So if I inverse norm 10% or 0.1, that gives me a z value of negative 1.28. That's my z. Third step, I'm going to use my formula, x equals z times sigma plus mu. My z value is negative 1.28. My standard deviation in this problem is 2.1, and my mean is 11.2. This gives me 8.51 years. So let's interpret that. If you were to work at this company for 8.51 years or less, then you would be laid off. If you worked more than 8.51 years, they would keep you on staff. Okay, last example, and this one seems to create a little bit of confusion because we switch gears from being given percent and introduce quartile and then percentile, so let's follow closely and we should be okay. A survey was conducted to measure the height of American males. In the survey, respondents were grouped by age. In the 20 to 29 age group, the heights were normally distributed with a mean of 69.2 inches and a standard deviation of 2.9 inches. What height represents the first quartile? So again, my first step is I want to write this as a left problem. So back in chapter 2, what did the first quartile represent? It's 25%. So quartile 1 is 25%. Quartile 2 is 50%. Quartile 3 is 75%. So anytime from here on out for the rest of the year, when they say quartile 1, they're indicating 25%. Quartile 2, 50. Quartile 2, 3, 75. So let's mark off 25%. So that means this is 25% of my curve. So if I write this as a left problem, I'm going to use 0.25. All right, because 25% is